Welcome to Maths with EJD. In this video, we'll be looking at the cutting plane method for integer linear programming. In the previous set of videos, we had considered integer linear programming, then followed by the branch and bound method. And I actually went ahead to take an example with the Python code for its implementation. So in this video, we are looking at another method for solving integer linear programming in addition to the branch and bound method, and it is called the cutting plane method. So the the cutting plane, the cutting plane method is a technique to solve integer linear programming, to solve integer linear programming problems where the goal is to find an integer solution to a linear programming problem. Okay, we're looking for integer solution to integer linear to linear programming problem, right? So this method iteratively refines this method iteratively refines the feasible region of the LP relaxation under the branch and bound method. We talked about the LP relaxation, and it is actually the linear program. It is linear program, the linear program without the integer constraints, without the integer constraints. When we have integer linear programming problems, we are looking for the condition is stricter. In addition to the variables being non-negative, we also want the the decision variables to be integers. So when we relax the integer condition, when we don't care about whether we get integer solution or not, then that is what we call the relaxed linear program, or the LP relaxation. So it is the linear program without the integer constraints. And we do that by adding. So this cutting plane method now is done linear by adding linear inequalities, or what you can call cuts. It's cutting plane, right? So the linear inequalities can be called cuts, which actually cut off, as the name implies. It excludes, excludes which exclude fractional solutions. To exclude fractional solutions, but keep keep all integer feasible solutions, but keep all integer feasible solutions. Okay. Of course, we already know what an integer program looks like, so I won't bother about that. I'll just go straight to talk about the cutting plane method outline. What does it look like? Cutting plane method outline. How do we apply it? You remember, for the branch and bound method, we talked about initialization, right? That's where we solve the relaxed linear program problem. After that, we branch and bound. After branching and bounding, we um we 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 what's that thing now? We prune. After pruning, then we terminate. These are the 5 steps for branch and bound. So for cutting plane method, right? We have the first step is to solve is to something like the initialization, right? We solve the LP relaxation, or what you can call the relaxed linear program, the linear program relaxation, or the relaxed linear program. So here, what you just do is to solve the linear programming problem. Let me just say LP for short. Solve the LP problem without, so we relax the integer constraints without the integer constraints. So when you don't care about the integer constraint, that's when you say this problem is relaxed. Solve the LP problem without the integer constraints. Okay. This means this means solving this means solving uh this problem. This means solving maximize maximize. It could as well be minimize, right? Maximize or minimize C transpose X, okay, C transpose X subject to AX less than or equal to B, okay, AX less than or equal to B, okay, and of course the X's are actually um remember they're actually real, okay. Normally when the problem is not relaxed, right, the X actually has to be belong to the set of integers, which is Z. So because it is relaxed here, we are just thinking any kind of real number, okay, n-dimensional real number, depending on the number of variables we have. So this gives this this gives a fractional solution, or better still, we can say this can give a fractional solution. Okay, it can actually give a fractional solution. So that is the first step. Now, having taken care of that, the next thing we want to do is to add the cuts, like we say, we want to add the cuts. So, the second step is add a cutting plane. You know, it's called the um cutting plane method, right? So first step, solve the LP relaxation. Then number two, the second step, right? The second step is to add a cutting plane. Add a cutting plane. That's where the cutting plane method, the name comes from. Add a cutting plane. To add a cutting plane simply means if the solution, if the solution is not integer valued. So if you get answers that are not integer valued, right? So we introduce, we we introduce a cut, which is actually a new constraint. We introduce a cut, which is a new constraint that excludes the current fractional solution, that excludes the current fractional solution, but does not eliminate or does not eliminate any integer solutions. Okay. So that's the second step. Now we go for the third step. So we go for the third step. And the third step is to now, so now if you once you have added the plane, then again you solve the new, you solve the new linear program that emerges from the addition of another cut, right? So we solve this again. So after adding the cut, after adding the cut, resolve resolve the LP problem, resolve the LP problem. Of course, this can be done using graphical method, simplex method, or any method you choose. Okay. But for ease, I like to use graphical method. So if you have not seen, I mean, I've done several videos on graphical and simplex method previously. So you can also always refer to those. So if the solution, if the solution is still, if the solution after solving, right, is still fractional, is still fractional, then you return to step two, return to step two and add another cut. So, and add another cut. Okay. Then finally, you have step four where, you keep repeating until you reach your goal. So step four now, right? You repeat. So, and for repetition, right? You continue the process, continue the process until an integer solution, until an integer solution is found. Okay. Continue till an integer solution is found. So that takes us to investigate the types of cuts we have, types of cuts in the cutting plane method, types of cuts. So we say that the cuts that are added, the cuts that are added are specific inequalities. They are specific inequalities that exclude fractional solutions. They exclude fractional solutions from the feasible region. From the feasible region while keeping the integer solutions. While keeping the integer solutions. So common types of cuts, common types of cuts include, first of all, we have the Gomori cut. Gomori cut. Okay. So it is basically derived from the linear programming tableau. So these cuts are particularly useful. They're particularly useful, useful in integer programming. Okay. Then we also have, this is a bit difficult to pronounce, but it's something like Chivatal Gomori cut. Chivatal Gomori cut. Okay. Now the Chivatal Gomori cut is a generalization. It is a generalization of Gomori cuts that are stronger, that are stronger and more widely used, more widely used. Okay. Then we also have what we can call the lift and project cuts, lift and project cuts. So for the lift and project cuts, right, they are used more in advanced versions, in advanced versions of the cutting plane method, of the cutting plane method. Okay. Now, before we take an example, let's also talk about advantages, right? Let's talk about some advantages of the cutting plane. Advantages. of the cutting plane method. So, of course, the first advantage is its exactness. You can count on it for exactness. So, the cutting plane method is an exact method. It is an exact method. Okay. Meaning, meaning it will eventually, it will eventually find an optimal and find an optimal integer solution. Integer solution. Of course, that is if one exists. So optimal solutions don't always exist. That's why if you see most of the codes I've been showing you, if you observe it, there are parts that will tell where it will just you have a likelihood of optimal solution not existing. So it will just say optimal solution doesn't exist. But I mean, all I've been doing, I try to avoid that so you can actually have a solution. But not all not all problem have solutions, you know. So you should be aware of that. So it's flexible, right? Flexibility. It can, it can handle more general, it can handle more general integer linear programming problems that might be difficult, be difficult for other methods like branch and bound. So, as you're going to see very soon, for branch and bound, there's a lot of if you have many variables, so there's a lot of you'll have a lot of branching has to take place there. But in the case of cutting plane, you just cut things off and keep moving, compared to branch and bound where you have to keep branching several times. Okay. Of course, let's talk about the disadvantages. So it's not all advantages, right? Disadvantages of the cutting plane method. Disadvantages of the cutting plane method. So we have computational complexity. Computational complexity. That's one of the disadvantages. Computational complexity. Um, so here, the method, the method can be computationally, method can be computationally intensive, can be computationally intensive as it involves solving linear programs multiple times. So each time you add a cut, right, you have to solve a new linear program. Well, not totally new, right? But you have to solve an updated linear program. So you solve multiple times, and as it involves solving LPs multiple times and adding cuts and adding cuts. Okay. Then the next thing is the slow convergence. Slow convergence. So here, because of what they cut and all that, so the method may require, the method may require uh, many iterations. It may require many iterations before it converges. Many iterations before it converges to an integer solution. Okay. So, well, because the video is already too long, I think I'm going to do the example in the next video. Okay. So I'll try to stop this here now. So I can so the next video I'll just go straight to solve a problem. Okay. So let's just go to conclusion. So this will just be like an introduction to introduction to the cutting plane method. So in short, right, cutting plane method, the cutting plane method is a powerful technique, is a powerful technique for solving integer linear programming problems, integer linear programming problems by iteratively refining the feasible, refining the region, feasible region of the LP relaxation. Again, I told you that LP relaxation is where you you ignore the need for your solutions to be integers. So through the addition of cuts, through the addition of cuts, cuts are simply linear inequalities. So cuts are linear through the addition of cuts, right? Which are simply linear inequalities. Cuts are linear inequalities. Okay. The method the method progressively narrows down the feasible region, the feasible region until an integer solution, until an integer solution is found. So, although effective, it can be computationally demanding, like we saw just now. It can be computationally demanding, especially especially for large scale problems. Large scale problems. Okay. So I'll stop here so I can take a proper problem in the next video. So if you have not subscribed to this channel, be sure to do that right now. Hit the notification bell also, so you can always get alerted each time a new video is released. And comment, let me know if you want to teach a topic or solve a problem, and like and share so that more people can have access to this great content going on here. So watch out for the next video where I'll solve an actual problem using the cutting plane method. Bye.